Hello everyone. Today I'm going to explain data normalization. We practiced how to convert ERD to ER notation, and the reason again the reason we it is possible to normalize ERD directly, but reason why we need to practice convert to ERD to ER is without seeing sometimes without seeing actual data or the form of a table. I already practiced, but you may not because you may not fully practice. It's slightly harder to normalize directly onto on ERD rather than EER. So that is why we practice ERD to EER. So let's see. Let me go to again, let me review again. This ELD can be transformed to the form of relation, which is within the EER notation. So the column table name goes to the above the cell headings. You can consider those as headings, and the attributes goes to the heading cells, heading columns, and this form is quite similar to our database. If you go to our database, if you go to your tables and data tab, you'll see heading columns, right? And then you can see data below the heading columns. So this form is more closer to the actual tables that you can see in your table spaces. For instance, let me open my table. Okay. Okay, so let me open my table. If you go to tables, then you'll see your tables, right? That those are created by me and you because you did your assignments, right? Let me open employees. Then if you go to data tab, then you'll see heading columns at the top, and you'll see the data, right? So ER notation is quite similar to the actual tables. The only difference between ER and, well, there are several differences between ER and actual table. The major difference between ER table and EER is while there is actual data under the heading columns in the table, but there's no data under the heading columns in ER notation. So that's the difference. And also, unlike actual table, we don't see what is a primary key, right? But we can see what is a primary key in relation in ER. So that's good. One of major difference between them. Okay, so the reason we need to normalize is process delete anomalies, possible anomalies. Okay, so there are three. The reason why we may have anomalies is if you draw well structured, systematically structured ERD or EER, you may not have anomalies. But if you have less systematically designed ER or EER, ELD or EER, your tables and your relations like this may have anomalies. Okay, insertion anomalies, and there are three different types of anomalies: insertion and deletion and modification. So insertion happens when add new row, and while you add a new row, you are forced to add unnecessary information, or you may have duplicated information. That is called insertion anomalies. And deletion anomalies is when you delete some row, a data shouldn't be deleted, can be deleted at this same time when you delete. And modification anomalies is you have to change, even though you want to change just one row, you have to change multiple rows. That is called modification anomalies. Okay, anomaly. So we're going to see some example of those three anomalies. All right, let's take a look at this table. Okay, so you'll see, well, that is quite similar table that we have in our table space: employee ID, name, department name, salary, and course title, and course completed. So we can see employees information such as name and ID and their salaries and their department and courses offered for employees, and we can see when they finished the coursework. So based upon the information of date completed, we can the company can issue certification. Okay, so let's take a look at what is weird in this table. You can pause this video and think about what is awkward. In that case, we can call awkward aspect as anomalies. Okay, let's think about. All right, so first, data have to be atomic, right? Data shouldn't be duplicated. So first, let's think about what is the primary key in this case, by the way, because we always need to have primary key, right? What is the primary key here? If you think employee ID is the primary key, you can see there are duplicated identifiers, right? So that is a awkward thing. There are two Margaret Simpson, and there are two Chris Rosero, and there are two Susan Martin. All of them have the same employee ID. Again, employee ID cannot be duplicated. But what can be, if employee ID cannot be primary key, what column should be primary key? Actually there's nothing, right? So to make, well, there are several more employee key and primary key, but if you want to make employee ID as a primary key, we have to make those employee ID as a unique identifier. That means we have to restructure, or we have to in database we have the process called normalization. Okay, so we have to normalize this table, otherwise this table has three anomalies. All right, so what you have to do, well, is we're going to see the other examples. Okay, and let's think about in those three ways: insertion, deletion, and modification. So if you want to insert new data of employee, you have to have courses title and data completed, right? There is only exception Lorenzo Davis, who is in finance department. What if, can you is it possible if new employees has been already certified for a certain course? No, it is impossible, right? It is impossible. So without both information of employee and course and date completed, new employee cannot be inserted. If very luckily, if the course title and date complete is not mandatory, it is possible to insert, right? It is possible to insert. What about deletion? Let's say Susan Martin decided, already retired. That means we can't keep Susan Martin's information in our database. Okay, if we delete Susan Martin, then information about SPSS and Java will be deleted as well. That means it seems like a Java course is not offered any longer, right? That is the problem with this table. This table has too much different information: employee information, department information, and coursework and dates of completed. So it's better to separate, right? So if you see something awkward in table, you have to think about how many themes are carried within the table. Again, if you go back to your employees table, then there is only information which is related to employees, right? There is no other information. But this table carries job ID. The reason is employee job ID refers job information within jobs, right? What about other unrelated information? Job ID and department, right? Department could be related and could be related to directly related to employees. But if you want to make sure which department each employee belongs to, we must have certain information, right? So reference is okay. Reference such as department ID, manager ID, and job ID is okay to be located within that table. Okay, so and without reference, also it is impossible to track their references. Okay, so this table, unlike employees table, this table itself carries too many different information. Too much different information: employee, department, course, and date completed. Okay. So to remove those anomalies and to guarantee there are no more anomalies, we have to normalize. And there are several steps of normalization. First step is removing multi-valued attributes. And once you remove multi-valued attributes, then you will have first normal form or first normalized form. And then what you have to do, you have to remove partial dependencies. Well, seems like complicated, right? And also, then you will have, if you are done by remove partial dependencies, then you will get second normal form. And if you remove transitive dependencies, then you will get third normal form. And if you remove remaining anomalies resulted by the third normal form, then you'll have Boyce-Codd normal form. This process called Boyce-Codd normalization. Okay, so normally 1, 2, 3, 4 steps are enough for regular or general tables. Fourth and fifth normal form are not mandatory. Those are optional depending on type of database, type of purpose of table. Okay, so let me explain each step. Okay, but actually you don't need to normalize step by step. I'm going to explain how you can do 1, 2, 3 steps at the same time. All right, so let's think about what is multi-valued again. You will see if you go back to previous pages, then you will see what is multi-valued. Okay, what is multi-valued? Okay, well, I think it's multi-value is in the previous PowerPoint slide. Let me open it. Okay, let me open Okay, so I found a page. So let's say there's an employees table, and if you may have those columns, and if you have skill column, which may contain multiple skills, because it is possible for employees, for any of employee, to have multiple skills such as Java, database, or web, or server-side program language, program, or JavaScript. So you may claim yourself with multiple skills, right? So it could be okay at the level of prototype. When you draw prototype ELD, it could be okay, but it is only okay at the level. Any of deliverables, any of output in my class or other class, multi-valued attribute is not allowed. Okay, so uh, to have multiple skills in one table, then you may need to draw. Uh, you may need to wrap. You may need to have those. Well, you can draw, or you can have some this kind of tables like this. Okay. Well, this is another example. This example of invoice data. So let's see. In one invoice, the company may sell multiple items, right? In one invoice. So that those items is sold to Value Furniture, and those two different products are sold to Furniture Gallery. So if you want to have those columns, if you have those attributes in your ERD or relation in EL notation, product ID, product description, product finish, product standard price, ordered quantity are multi-valued attribute, right? And those columns have same common information, which is order ID, order date, customer ID, value furniture, and piano. So to remove or to complete to make first normal form by removing multi-valued attribute, you must remove any multi-valued attribute like this. Okay, so each you cannot have any empty or any merged row. If you have if you have separated rows, then you can say you just removed multi-valued attribute, which means you are done by first normal form. Okay, so if you're done by first normal form, what you have to do is you have to remove partial dependencies. Partial dependencies is information dependent on primary key. So let's take a look at this column. Order ID and primary keys are given here. Product ID and order ID and product ID are composite primary key, right? That means if you refer product ID in product table, you can get product description, product finish, product standard price, right? Because we already practiced how to make a join query, right? So if you just make a join query with order and product ID, it is possible to get information on product. Also, order date is dependent on order, right? You can have different order date for each order ID. What about customer? If you know customer ID, we could possible to get information on customer with join query, right? Customer name, customer address. So those two columns are partially dependent on customer, and those two one column dependent and partially dependent, and those columns are partially dependent. So that means there are three different themes: order, customer, product. What about this? Order quantity is also fully dependent on order ID, right? So if you think those terms too hard to understand, partial dependencies and remove of transitive dependencies, you don't need you don't need to think that is too hard to understand. What you have to do is you have to think about how many themes are in this relation. First, what I can find is order, right, and customer and product, and order line, which use order ID and product ID as a primary key and foreign key at the same time. So I could find one customer, I can find four themes: order, customer, product, and order line. Alright, so if I separate in four themes, okay, ID. Okay, so using Excel, I just created ER notation, and what you have to do is think about how many themes here. But what I want you to do earlier than thinking about themes, number of themes, you have to think the name of relation. So what I think in this page is that relation is for order line, right? Because I could see order to quantity, right? And so let me go to Excel. Then I just create a scene relation. So again, I decided to that name is order line, okay? And although order, name of a relation is not given here, but if you look at the Word document I provided before, you will see what is the name of relation in this chart. Okay, so order line. So we need to separate themes. How many themes here again? Four themes, right? First, customer. Okay, and whenever you separate themes, you have to make a same level of relation, right? And customer ID is here, and I will copy this one. Okay, right. Okay, let me wrap the text font. Let me shrink to fit. Okay, so I'm going to increase width slightly. So I just created another relation, right? So as long as I have customer ID as a primary key, I don't need to keep the information, right? Because I always can able to refer customer ID. What about product? Okay, and product description, product finish, product standard price are partially dependent on product, right? So those are processed to separate into themes, multiple themes. Okay, so as long as as long as I know product ID, I don't need to keep product information, right? What about order? Order ID and I think I need order date is dependent on order ID, right? And primary key of order is order ID. Alright, so let me delete these two cells. Okay, let me cut and paste here. Okay, so I just made it four. Just separate into four themes: order ID, customer ID, and order, right? New order. And okay, order line in order line, order ID in order line refers order date, right? So we can see when the order, including multiple items, are placed, and also it is possible to how many items and what items are placed by a certain customer by seeing order line, right? And also it is possible to refer who placed that order, right? Oh, I think customer ID is better to locate it within customer because well there is no possibility. Well, sometimes it is possible. So when you see the certain question, you may think the explanation is not fully described. So if you have customer ID order line, it is that means it is possible to place order by multiple customers. Because normally it's hard to happen. So customer ID needs to be located here, right? Because well, in many of cases, and we in many of cases we assume the order was placed by just one customer, right? So that could be well correct, I think. So if you want to move customer ID to order line, you need to have your own assumption. So whenever you have whenever you see your whenever you see the given question, you can add your assumption to to explain your ER or ERD or normalization process to reviewers like me. Okay. So let me complete ER notation. What I have to do is insert. Okay. Where's the pen, by the way? Let me insert. Here. So customer ID refers. Okay. Let me insert the other line. Customer ID refers customer, right? And order ID refers order, and product ID in order line refers product. So that's it, right? We are done by first normal form. Okay. We are done by first normal form. Yes. So well, I have customer ID order table because that author also assumed customer the order can be placed by just one customer. All right. Okay. So what I want to tell you is to for the third normal form is we have very simplified version of the attributes in my relation. Let me separate. Let me make it all better, slightly better for the relation of customer. So what I want to do is I'm going to make I'm going to separate customer name into first and last name, and I'm going to separate customer address to multiple columns. such as street, zip code, city, and state. Okay. First name, last name, street, city, state, country, and zip. Okay. Looks like much better, right? Okay, so it looks much better. But if you look at this table, you will find some columns are necessary. Can you find it? Okay, I want you to guys spend couple of minutes to find what is weird or what column can be deleted or can be removed. If I give hint, you can find in customer relation. Okay, customer relation. Spend couple of minutes and you can pause this video. Okay, so let's think about the address. When you type certain zip code, when you sign up certain website or some forum, you have to input your information, right? But think about zip code. Normally, if you type zip code, then the website may automatically fill your state and city, right? You only type the USA, well, that by default. If you fill in zip code, then you will have automatically fill city and zip. That means if we have zip table, okay, zip table with zip code, okay, and city and state. By referring zip code in zip relation or table, we don't need to have city and state, right? That's enough. But street information cannot be automatically filled, so we have to keep the street column. So removing columns can be automatically calculated or referred by other table. You are done by third okay, where is it? You are done by third normal form, so-called remove transitive dependencies. Or if I give another example, okay, well, let me have birth date, okay, and age. So because I just added two columns, you should able to think what is weird here. What is weird is related to those two columns, right? If we know birthday, it is always possible to calculate their age, right? The age means how many years have passed since the customer was born, right? So age is necessary, not necessary. You can just delete. You don't need to even refer at the table. That's it. So you have to keep the information as simple as possible. If any other column can be calculated like age, you have to delete. and it is possible to refer other table. You have to delete unnecessary column like city and zip, city and state. All right, that is process of third normalization, removing transitive dependencies. Okay, and voice cut normal form. Let me move to voice cut normal form. Well, that page explains a third normal form. Okay. Alright, well, to explain voice cut normal form, we need to go back to the example in page what is page number? Page, well, it doesn't, page 35. Okay. Alright, I already made an Excel spreadsheet using this information. Okay, again, let's think about what's weird here. Again, we have multiple themes. We don't have multivariate, right? That means this table is already done by first normal form. You need to think about from second normal form to voice cut. Okay, voice cut. So what I have to do is first separate those information into separate themes. Okay, employee, and let me copy information to here. Okay, so what I have to do is I need to copy salary as well, because salary is related to information as well. That is information of employee. So what I have to do is removing unnecessary information, duplicate information. Okay, I'm going to delete. And I will move this down to here because I want to order the column by employee ID. Okay, so I have 5 employees only. Okay, what is the next theme? Department, right? Let me copy to the next column, and I will delete marketing, duplicated department. And I will delete department. So marketing, accounting, information, finance, marketing. Okay, I need to delete marketing again because there is marketing here. Okay, and course. Okay, let me copy to here. Course, department, course. Okay, I'm going to delete duplicated course information such as SPSS, and I think that's it. Alright, so but that information is about not only for employee and their certificate information based upon when each employee are done by taking each course. So you have to be certificate. Okay, So in certificate relation, what information need to be, what implement should be included is employee and course title and date completed. In other words, this column is necessary, unnecessary. Okay, entire column left. Okay, and department is also necessary. What about course title? It should be, right? It should be. And salary also is unnecessary. Okay, so let's take a look at. Okay, let's compare what is weird here. What is weird? What have to be modified? First, well, we are done. Actually, we are done by third normal form. But what is not done by is we don't have any foreign key in this sheet, right? But we have foreign key here. So what you have to do is you have to make sure each reference has proper foreign key and with its type. Again, this name, marketing, accounting, information system, finance cannot be primary key, right? Because once it is determined primary key, the primary key cannot be modified. For instance, if you made a typo for the finance, like this, because you cannot modify primary key, right? You have to keep, your system needs to keep incorrect department name. To avoid it, it's better to have primary key, department ID, like this. So department ID let me format cell. Okay, and I'm going to make it is as text. And so as long as you have proper primary key, okay, primary key, you don't need to keep their information, right? I mistakenly deleted their department ID, so let me add department ID. So each employee needs to have department ID, right? So let me go back to, because I mistakenly deleted department ID in employees. So let me refer this page. Margaret Simpson department ID is marketing. The department ID have to be this, right? What about Chris Lucero? Information system, right? Which is 003. What about Allen Bitton? Accounting. Accounting have to be 002, right? Susan Martin, marketing. So department ID have to 001. What about Lorenzo Davis, finance? So by having foreign key in employees, we can find out what department they belong to. Okay. What about course title? Course title needs to be also needs to be also needs to have primary key, right? Which means course ID. So by having course ID which is for key in here, we don't need to keep course title. Okay, let me have okay, let me have border for these columns. A to C D so I use the first letter as a category. Well, it's not metric. Well, that is one of my intuitive primary key format. So aspaces needs to be here, right? What about survey? Survey have to be here. Text accounting and Visual Basic and C++, and that should be deleted because Lorenzo Davis haven't taken any course yet, so we don't need to keep unnecessary record. What about spaces again? In Java. So I could separate it into 4 themes, and each theme has proper well, not each theme, I mean this theme carries very necessary information only with proper primary key, right? So actually this is already done by Boy Scout, but this was to make sure to complete Boy Scout normal form, you have to give proper primary key. Okay, that is the Boy Scout normalization. Then if you have atomic information in each relation or table, you're done by Boy Scout normal form. Alright, so actually some instructors may ask each step by step to finish normal form or to normalize, but I don't ask to follow these steps. First, to do the first step, you have to remove multi-valued, but second, third, and Boy Scout, you can follow my method, which means you have to separate themes. Okay, if you want to separate themes, and then if you have proper foreign key, you're done those 3 steps. Okay, so it's quite easy, right? Think about themes. So that is about normalization form, right? So I want you to guys do the last assignment, and this last assignment will give a lot of hints how to prepare the exam, and the exam will be quite similar to your assignments. Alright, and thank you for watching my video, and I will see you guys. And this is the last lecture, but last video clip will be for explaining your assignments. Okay, thank you for watching my video clip, and I will see you guys in the next video clip.